Welcome back, folks. We're still playing with our really simple transistor circuit with the BJT, and I want to find a different way to push this one into saturation. Last video, we saw the decrease in the base resistance caused more current to flow through the base, which was then amplified, and more current flew through the collector, and that caused a larger drop across the collector resistor, which meant that RC was lower. So we want to find a different way to do that in this video. So let's take a look. Again, I copied over as much as I could onto the pad here. And this is the original circuit. And this was originally 3.5 volts, the way that we had it. But we want to make a different change. We want to leave RB alone and figure out how we can make this happen. So the other thing we can do, if we're not going to change the current flowing through here, well, we have to think about what else makes that voltage go up, right? And V equals IR. Last time we increased I, this time we can increase R. If we increase R, we can push it into saturation as well. And the R that we're looking at is this resistance here. So rather than changing RB, I'm going to come over here and change RC. Instead of 150, let's make it bigger. Let's just 1K feels like a nice round number to work with. So looking here at our original set of equations for our analysis, that 150 only shows up down here. Okay, so we make that 150 and then we go solve it. Okay, much of the analysis stays the same. We just change that value. So we're working with the same equations. Okay, so let me grab MATLAB and give you the full view there. And let's take this script and make a new one. Okay, and all I'm changing here is the 150. Okay, that's now 1K. And I'm getting lazy here, so let's evaluate the solution for VC. Okay, and I gotta save it. And I'll make it match the image file name and hopefully the video name. And we get negative 855. Well, that's a properly absurd number that I didn't get. Oh, wait. Look, that's still... We're leaving the 86 the same. Okay. I was going to say that felt absurd in the correct way, but so absurd that it didn't match what I had worked out earlier. Okay, let's try that with the 86K still in place. Okay, we get a VC value of negative 5 volts. That feels better to me. All right, so let's move back here, and we find that it's negative 5 volts. Okay, so we can start to run through our checks, right? We can say VBE is still 0.7, so we call that forward. What color did I do this in the last one? I can't remember. VBE equals 0.7 volts. Okay, so we can call that forward. Okay, and VBC, let's see, is now 0.7 minus negative 5, which is equal to 5.7 volts. Okay, and we can also call that one forward. So these aren't the cases that are ambiguous yet. I kind of teased that in an earlier video, that we're going to run into trouble using this chart. We haven't found that case yet. And so far it looks like in saturation we're in good shape for this chart. All right, so that's one way to do it. The other way, of course, is to look at VCE, and we can say VCE is VC minus VE, which is negative 5, minus 0, which is negative 5 volts. Okay, VCE is less than 0 in this case, and therefore we can say saturation. Okay, you'd then have to go repeat the the analysis the way that we did in the previous video. I'm going to let you go back and see how that analysis gets repeated from that video if you haven't watched that deep into it. I know some of you only watched the first 5 minutes, but it's the same. Okay, so I don't want to redo it here and waste bits on YouTube. Anyhow, we moved it to saturation. What do we got to do next? We got to move it to cutoff. Okay, what changes are we going to make to move this to cutoff? So I want you thinking about that before you start the next video, and that's what we're going to look at. Stay tuned and good luck.